Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at Router-on-a-Stick Inter-VLAN Routing. We'll be discussing Router-on-a-Stick, VLAN and trunking configuration, and finally, Subinterface configuration. This episode is part of my series on switching, routing, and wireless essentials. I'm Kevin, here at KevTechify. Let's get this adventure started. When we go and we set up router on a stick, on the router, we have to do some configuration there. And what we do is we use one physical interface on that router. On the router, we use one physical port. All we have to have is one physical port on the router. We connect it into that port, that trunk port on the switch that sends all the VLANs worth of traffic across that connection into that one physical port. Then on that physical port, we create what we call sub interfaces. We take that one physical inner port, and then using software, we create sub interfaces. These are virtual interfaces that we create there. And like I said, they're configured in the software. With those sub interfaces, we put it on our layer 3 IP addresses. We assign it to a VLAN there. And that way, each VLAN has a connection on that router where they can send all of their traffic to that entire VLAN. They can all send it to that router. That's their default gateway. And then that router can change either VLANs or route it onto even a different network. When traffic does make it to that router, the router then looks at that. It looks at that 802.1q tag in that frame header and says, okay, what VLAN is that destined for? We're going to make a routing decision. We're going to look and see where is that IP address in our routing tables, and then we're going to send it on its way. Now, it could be an exit interface, which could be one of the sub interfaces. If it's a sub interface, one of those 802.1q sub interfaces, we then put that frame tag on it, that 802.1q frame tag, to identify which VLAN it belongs to. If it goes out a different interface, and so you have your router on the stick, but then you have like a serial connection coming in from your ISP or something along that line, you can then route it out that connection. What we're talking about is this connection right here, this G001 connection right here on the router. This is the physical connection. This is the physical port that we're talking about. But then we create these software ports based upon that. And what these look like is we put the physical port number here, and then we put a period, and then you can put a number here. Now, this number can be any number you want, but a good idea here is let's keep it simple. And what we do here is this interface, the sub interface number, why not match it to our VLAN? Why not match it to what makes our network address unique? And if we look at this, this is a /24. So the first 24 bits in our network address is the network portion. This is our network portion. Same thing on all three of these network addresses. The first 3 octets are all the network portion. But what makes each one of these unique? It's this third octet here. This third octet makes each one of these networks different, makes each one unique. So why not match that up with our VLAN number, with our sub interface number? This just keeps it simpler here. If we match these 3 fields up, it just helps keep it simpler. Now, you could make the argument, well, then that's a security risk because it's making it simpler. That's something for you and your company to figure out. But right now in this learning process, we're going to try our best to keep all 3 of these the same. But do remember, this VLAN or this sub interface number could be a wide range of addresses. This VLAN number could be anywhere from 1 to 1024, and this third octet could be anywhere from 0 up to 255. And so we just try and keep these these numbers all the same to make it a little bit simpler in our heads. If we look here, we have 3 different networks. We have the 10 network, the 20 network, and the 30 network. Those numbers all match up. These virtual interfaces are all associated with this physical interface right here. There's also one more thing you have to remember when you deal with sub-interfaces. When you deal with sub-interfaces, the virtual interfaces, these sub-interfaces, these are on by default. They're on. But the physical interface is off by default. And what happens a lot of times is you create all your sub interfaces. You go through, you set up your sub interface with a .10, you assign the VLAN, you assign your IP addresses to them, but it does not work. What you have to do is come back here and make sure that this physical interface, you do a no shutdown on it, you activate it, and you turn that physical interface on. You have to manually go in there and do that. If you don't do that, none of your sub interfaces will work. When you set the switches up in a router on a stick environment, you have to follow a couple of steps. First step is we need to create and name those VLANs. So you have to go in there, get in the global configuration mode, type in VLAN, and then whatever your number is, VLAN 10. Hit enter. While you're there, let's go ahead and give it a name, HR, manufacturing, management, whatever you want to call it. Once you do that, then we go ahead and create the management interface. That management interface is where you assign your IP address to it, and that allows you to connect remotely into your device. Now, to create that interface, you have to exit out of where you created your VLAN, the VLAN configuration. You actually have to go into the interface of the VLAN. So you type in interface VLAN and then your number. So interface VLAN 10. Go ahead and type that in. And then you can apply your IP address, do a no shutdown on it. Anytime you do anything with an interface, just always make sure you do a no shutdown. Nice habit to get into. Then once you have that, you also have to put on your default gateway. If you want that to be managed, if you want that switch to be managed outside of your network, if you're going to connect in remotely, you have to make sure you put your default gateway. And on a switch, the default gateway is not associated with a port. It is associated with the entire device. So you have to get out of the interface configuration mode, get into global configuration mode, and then put in the command IP space default gateway, and then the IP address of the default gateway. After that, you have to go and change what ports on the switch, what switch ports you have. You have to tell them, okay, these need to be access ports. The switch needs to know, okay, these are access ports. I'm going to look at that 802.1q frame tagging and only allow a certain VLAN worth of information in there. Then you set that VLAN up. So you set that, you go switch port mode, switch port, space mode, space access. That turns it into an access port. And then it's switch port, access VLAN. And then what VLAN are you going to have information going out that port and across that connection? Once you have those set up, you also need to set up your trunking. You at least have to have one port trunking. That's the one going to the router. But if you have other switches you're connecting to, you need to also make the connections to those switches a trunk. When we look at our diagram here, these are the switches we're talking about. Coming in, you create your VLANs, you name them, then you set up your IP addresses on those interface of those VLANs, so that way you can do your management. And then once you do that, you're going to say, okay, you have to pick out what ports you have, turn them into access ports, then assign them to whatever VLAN they're in. And you have to do that with every switch. Coming over here to switch 2. We'll go ahead, create our VLANs, then we'll set up our management. Then we'll say, okay, this is an access port, F018, and then we assign it to VLAN 20. The one thing you have to know here is you have to have all of the VLANs exist on all of the switches, even though you're not going to use them. Here on switch 1, if we create just VLAN 10, and then on switch 2 we have VLAN device in VLAN 20. When we send VLAN 20 tagged information across our trunk to the switch, and we haven't created VLAN 20 over here on switch 1, switch 1 is just going to say that VLAN doesn't exist. I'm going to drop the frame. I'm going to delete that frame. What you have to do is make sure on each switch to create all the VLANs you're using. Over here, we need to make sure we create the 10, the 20, and the 99. Even though that we're using the 99, we're using the 10, but we're not using the 20 on here, we are still passing traffic for VLAN 20 through here. So you have to also remember to do that. If you like this episode on Router-on-a-Stick Inter-VLAN Routing and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. Subscribe to my channel and click that notification bell. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Here are the commands to go ahead and do this. This happens to be for switch 2 in our example. Notice we're in global configuration mode. Type in VLAN 10. That creates the VLAN if it doesn't exist, and then you enter into it. At that point in time, let's go ahead and name that. Then you type exit and you can get in VLAN 20, name it. Now, you don't necessarily have to type exit. If you would just type VLAN 99 right now, it would create it if it doesn't exist, and you could go into it. That just saves one little step here. A lot of people I know, they don't type exit between these going into these. Then once you've created and named all of your VLANs here, then you go in and you set up the management of that. And we decided here that VLAN 99 was our management port. We go into VLAN 99, we assign our IP address to that, do a no shutdown on that port, because once again, physical ports are turned off by default, so you do no shutdown. It's also just a good habit to get into. You exit out of the interface configuration, and then you set your default gateway. Once again, that default gateway is if you're going to manage that switch from a remote network. You're going to sit in your office, feet up, headphones on, at your desk, and manage a switch that's halfway around the world. You're going to have that default gateway in there. Make sure you set that default gateway for the network that your management port is on. And if you notice, these two are on the same network. After you do that, you go into the ports themselves. Go into the ports themselves and you assign what mode they are. And so right here we have Fast Ethernet 18. We set it's a switch port command because you're dealing with those switch port settings. We're going to change the mode to access. Once we change it to access, then it's another switch port command because once again, you're dealing with the settings on that port on that switch. We are looking at the access settings because we set that as an access port, and we're going to say you are in VLAN 20. And so the 802.1q tagging is going to be 20 for the information we're sending out of there and receiving on that port. Once you do that, make sure you do a no shutdown. And then we go and we set up our switch. Here we have Fast Ethernet 1 is our switch. We go in there, we set the mode to trunking, do a no shutdown on it, and that's all you have to do. Just turn it into a trunk and it'll send all that information across there. For all the VLANs, it will make sure that it has the tagging in that frame header for you. In that example we just looked at, we set up basically switch 2 right here. We created our VLANs, 10, 20, 99. We then went through and set up our management port on VLAN 99. We then said, okay, port Fast Ethernet 0/18, you're an access port. And then let's put this into VLAN 20. That's what we did on that previous screen, is went through and set all of that up. Once you go ahead and do that, we need to do some configuration on the router. This is where we're going to deal with the sub interfaces. This is where we're going to set the IP addresses so that they have a default gateway where we can route to it. And then also you have to go in and set that physical interface. You have to activate it. You have to turn it on. You have to do a no shutdown on there. Here in our code example, we can see that we're going into our interface of G0/0/1.10. And so this is the physical interface of that G001. That's the physical interface. But then in software, we created the sub interface. We add that .10 on there. Once again, this could be any number. We chose to do 10 because we're dealing with VLAN 10 worth of information. Adding a description in is always a good thing. And so we just say, okay, this is the default gateway for VLAN 10. And that'll help us when we come back and look and say, well, what did we do here? Well, okay, yeah, this is the default gateway for VLAN 10. Then we come along and tell it what type of encapsulation. You really only have one choice of .1Q for our encapsulation, meaning what frame tagging are we using. And so we start off by saying encapsulation, we say .1Q, and then you say what VLAN are we doing? What VLAN are we going to tag this with? And so that's our VLAN number here. And this number needs to match the tagging that's going to be happening on your switch end. And so good practice here is to set up your VLANs first on your switch. That way you know what your numbers are when you come to set your sub interfaces up on your router. Set up your encapsulation. You tell it to use .1Q. What VLAN will you be tagging and expecting on this interface? Then you can go ahead and set up the IP address for the default gateway. And once again, to help keep it simple, notice our third octet. That was the octet that makes this network unique in our example. That is 10 also. Keeping all three of these at 10 just helps simplify the process. In a production environment, it's up to you and your company to decide, do we want to follow that pattern or not? I know companies that do. I know companies that don't. Once we set up VLAN 10, our sub interface for 10, we go ahead and set up our interface for our sub interface for VLAN 20. Set that up. We set up our management interface right here. Set up our default gateway. We set all three of these up. Then once we have our sub interfaces set up at this point in time, we then go into the physical interface. And now notice we're going into interface G0/0/1. At this point in time, we're just going into the physical interface, not a virtual software-based sub interface. We put a description on it, say it's a trunk line to switch 1. And then we do what a lot of people forget. We do the no shutdown. We activate that port. Remember the rule here, virtual ports on a router, they're on by default. Physical ports on a router, they're off by default. They're deactivated, so you have to go in and turn them on. Once you do that, you should get some system updates. What we did in that previous code example is set up all of the interface right here. We did all the configuration. We set up all of our sub interface information, our VLAN information, our IP addresses, all on these sub interfaces, and then we turned on G00. We turned that on. To verify connectivity between PCs, remember our PCs were on different VLANs. PC1 was on VLAN 10, PC2 was on VLAN 20. To verify those connectivities, what most people do is use the ping command. They send a ping from one PC to another PC. Here in our labs, if you're following along in Packet Tracer, you're setting this up in your home lab, ping works, it'll go through there. In a production environment, one thing to remember here is if you're pinging a Windows system, Windows firewall is on by default blocking pings. And so you might be reaching the machine. You might have all of your trunks, your access ports, your VLANs, all of that set up correctly. But the end device's firewall may be blocking that ping from coming in and then going back out. And so you have to remember to turn the firewall off if you're going to use ping. Here we can see that we're on PC1 and we're pinging PC2. We're pinging a different VLAN. Remember, PC1 was on VLAN 10. PC2 was on VLAN 20. We can tell that's a different network because our scenario gave us that third octet was 2020. Remember how we're keeping those numbers the same. And the ping all successfully worked. We have 0% loss. That works. And then we even ping our management. We ping the SVI on one of our switches. And that all... Well, that didn't successfully work. We had a 50% loss. These two pings timed out at first. I'm assuming it had to go through an ARP request, an address resolution protocol, taking this IP address, finding the MAC address where we can send it across the network. By the time we completed it, we had 2 pings failed. If we would repeat this command, I'm almost positive that all 4 pings would come back successful because we did the ARP already. And that resolution is in that ARP cache. Some of the troubleshooting, some of the verification you can use here. We talked about ping. Ping is the number one you go to. If the ping fails along the way, I typically use traceroute. Now I have 2 different traceroutes listed here. TraceRT is the Windows version of traceroute. Traceroute is the Cisco iOS version of that. Basically, they do the same thing. They just have different commands to start. What it does, it'll show you an estimation of where your traffic stops when it's trying to get to its destination. It'll give you an idea of where along the path it's used. And what I see a lot of times and how I do it is I use ping. I either go big or go home. Either it's going to work or it's going to fail using ping when you ping your destination. And then I use the trace route to see where my network stops forwarding my information. And that'll give me an idea where to do that. If we're looking at our Cisco devices, on the router here, we can use the show IP route. And that'll tell us what networks we have available, what networks we know we can get to or how we can get to. It'll tell us if we have a gateway of last resort set up. We can use the show IP interface brief. What that does is give us a list of our interfaces and IP addresses in a nice little table format. We can confirm if the status is up, what the IP addresses are, if they're correctly. We can do a show interfaces. The show interfaces gets us into more details about each interface. We can also do a show interfaces trunk, where it'll list out all the trunks we have and what those statuses are. It was my pleasure to provide you with this wonderful episode on Router-on-a-Stick Inter-VLAN Routing. If you like this episode and you got value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. You can get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.